right. Good morning, good afternoon, good evening. Welcome to our TypeScript bootcamp. Quick question. Who has joined us for the intro bootcamp and the Python beginner? You can send us an emoji in the chat and let us know who is joining also in today's session. Okay, because we are preparing some rewards for all the algo devs that join us in all the bootcamps. It can be from the Python one or the TypeScript, but we are pretty excited to see all the AlgoDevs community helping us, joining us, and learning with us. Today, with me is the great and only Joe Polny, Senior Engineer at Algorand Foundation. How are you doing, Joe?
Hey, I'm doing good. Happy to be here and get even more people building on Algorand.
Awesome. And I know, Joe, that you have been working super hard creating TypeScript that allow us to use TypeScript for writing smart contracts on Algorand. So, Joe, what we can expect and what we are going to learn during these 4 sessions?
Yeah, so in these 4 sessions, we're going to be building a digital marketplace app. And so, like you said, we're going to be starting with TypeScript to build a smart contract in order to list tokens for sale. And then we'll be using TypeScript with the jest library in order to test that contract. And then we'll be integrating into a React front end, also using TypeScript there. So full stack TypeScript. And by the end of it, we'll have a fully functional app with a front end that you can interact with on your local machine.
That is super powerful because usually we just learn the part of how we can create our own smart contract. But during this bootcamp, you will be able to create the full dApp and integrate the front end with the smart contract. So you will have almost a full working example that you can replicate and you can use for your own projects. And that is the good part of Algorand, that right now you can use Python and TypeScript to create your own smart contract. Right now, you don't have to learn a new programming language. And these boot camps, apart from the knowledge, have an additional motivational event. And what is that event? Our global hackathon that we announced the last week. Hold on a second, I will share my screen. One moment, please. Because the last week we announced our global hackathon, and it has a prize pool of over 60,000 USDCA. And we will have 3 categories: consumer, DeFi, interoperability. Some important dates that you need to have in mind: the registration started the last week on April 17th. The hacking windows will be from May 15th to June 12th. And the finalist announcement is going to be in June 19th. The Grand Demo Day that is going to take place on Decipher is going to be June 27th. And we found out that the people who participate in the bootcamps have the technical knowledge that can be useful to participate in the hackathon. So who is ready to register for our global hackathon? And we want that people that participate in the bootcamps later on can become the winners of the hackathon. So in this moment, I will share the registration link so you can participate it. And that is another important thing to mention. Okay, there you go. So we are almost ready for the content that Joe has prepared for us, but we have some last announcement. The first one, this bootcamp consists of 4 sessions. The live store links for each day will be sent through your email. Please take a look of your spam folder because there are some times that you receive the links over there. And in session 4, I will share with you the link so you can claim the certificate of completion. I will explain you the process. And the most important part, and I love this a lot, is that you can add that certificate to your LinkedIn profile And this is not just a NFT or a poem, this is a verifiable credential. It's important to mention that all the sessions are recorded, and once the session is over, you will receive the recording in your email. And our next bootcamp in this series will be Intermediate Python, that is going to take place from May 20 to 23rd. And if you want to participate in the Intermediate TypeScript, and it's going to be May 27. Joe, what we are going to learn on the intermediate ones?
Yeah, so in the intermediate ones, we're going to be going a bit more into the details about the things you need to know in order to actually go into production. So, what we're building here today is a really great starting point for building on Algorand. But the intermediate session is where we're really learning all the details to kind of put it together and deliver a more production-ready app at the end of the sessions.
Wonderful. So we will have around 3 weeks to go through the videos, to try to create our own smart contract. And if you have questions, you can join us in our Discord. I will share the Discord link on the chat. Over there, our team can help you guys with all the technical questions, because sometimes we have small mistakes and we need someone that can help us to answer it. And the last thing is, if you want to understand Algorand native features in detail, don't forget to subscribe to our AlgoDevs YouTube channel. There you will find playlists explaining these concepts, and in the coming days, we will also upload the bootcamp recordings. The last important thing, please help us sharing screenshots of these sessions on X, and don't forget to tag us as at AlgoDevs. So, well, Joe, we're ready for the action, and we all have all the same purpose of becoming AlgoDevs. Are you ready, guys, for today's session? Over to you.
So before we get into the content, let me just get this link here. So I'm going to assume that everyone here has seen our intro bootcamp, or at least has set up their development environment and has AlgoKit installed. If you don't yet have AlgoKit installed, don't worry. All of these sessions are recorded, so you can come back after you installed AlgoKit. If you're registered for the intro boot camps, you can go back and watch those recordings, or you can go to our, let me get the link, AlgoKit Quick Start Guide on our developer portal. Link here. And I'll put it in the chat. And that contains everything you need to know to get set up with AlgoKit, which is what we're going to be using for our development. And if you're not familiar, that is the all-in-one command line tool for building on Algorand, and includes many important functions, particularly setting up a local net that we can build on. So make sure you have AlgoKit set up and installed. And the one thing that you also need for this week's session, in addition to AlgoKit, is Node.js. If you're already a TypeScript developer, you probably have Node already. But if not, you're going to want to head to nodejs.org/download. I just put the link in the chat as well. And make sure you have Node installed. The exact version doesn't matter, as long as it's something somewhat recent. You should be good to go. And and once you have AlgoKit and Node installed, you have all your dependencies ready to go. So again, if you don't have it set up, don't worry. You can come back and watch this recording after setting it up. And one thing I do want to address before we get into the TypeScript content, so someone actually asked this question. So I know some of you might have attended our Python bootcamp. And in our Python bootcamp, we built the same smart contract, except of course in Python, and then we integrated it into a front end. And we did that front end integration by using a typed client. And the nice thing is that if you attended the Python bootcamp and you learned how to interact with a typed client for the front end, then you already learned how to interact with our TypeScript smart contract. So the front-end integration for both TypeScript and Python are the exact same. So it's going to be the same content. That being said, make sure you attend at least our last session so you can get your certificate. Even if you already attended the Python, you want to get your certificate for the TypeScript as well. So make sure you attend that session. But all the content for the front-end integration is going to be the same as the Python. So in our first session today, we'll be covering smart contract development with TypeScript. In our second session, we'll be testing with TypeScript. And then our last two sessions are going to be front-end, which is the same as what we did in Python. And that is the beauty of AlgoKit, where regardless of how we wrote our contract, as long as it supports those standards for generating the typed client, the integration is going to be the same. So makes our lives a lot easier, especially if you're on a team where you have some Python developers, some TypeScript developers. You can both do your own thing and end up having the same sort of integrations. So with that being said, we can get started with the content for today. If you haven't attended our boot camps yet, quick rundown of how it works. I'm going to play a pre-recorded video that goes through all the coding and explains all the concepts we're going to be doing. As that video is playing, I'll be monitoring the questions tab to answer questions. And so I'll be typing answers if you put in the questions tab, or if it's an important question that I think everyone should hear the answer to, I'll pause the video and address the question live. And then we can continue on with the recording. So I'm going to go ahead and play that. And again, if you have a question, you can post it in the chat, but if you want to make sure that it's answered, make sure you use the questions tab in the bottom right. So the bottom right of Livestorm, you should see the chat icon, and right to the left of that is the questions icon. And that's where you should be posting questions to ensure that they get answered, but I'll also try to be keeping an eye on the chat. And I think with that being said, we can go ahead, and I'm going to go ahead and start playing this video. Again, I'll answer questions and pause as needed. Hey everyone, I'm Joe Polny, an engineer at the Algorand Foundation, and today I'm going to be showing you how you can use TypeScript to write a digital marketplace on Algorand. So we're going to be starting with smart contracts, so showing you how to use TypeScript to build a digital marketplace contract. And then we're going to be going over to testing, so using Jest to build tests for our smart contract. And then finally, we'll be going to a front end and how to use React with TypeScript to integrate our smart contract into our front end. So to get started, we're going to go ahead and use AlgoKit, and in particular, use the AlgoKit init command. If you aren't familiar with AlgoKit, make sure you check out our other videos on AlgoKit and what it's all about, and especially make sure you watch the video on how to set up your development environment that includes installing AlgoKit. The quick summary is that AlgoKit is a all-in-one command line tool for everything you need for Algorand development. And here we're going to be running the init command, which is going to give us a wizard to start a new project. Now, I mentioned that we're going to be doing both a front end and a smart contract, but we're going to get started with just the smart contract. So I'm just going to choose this smart contracts option. Now here we can choose what language we want. In this video, I'll be choosing TypeScript. And then we need to come up with a name for our project. I'm just going to call it digital_marketplace. You can name it something different, but the name of your contracts and your folders are going to be different if you choose a different name here, but you are free to do so. If you want to follow along with the tutorial though, I recommend just choosing digital_marketplace. So once you do that, it's going to create a new directory, digital marketplace, that has a projects subdirectory, and then our digital marketplace there. And we're going to say yes to running AlgoKit Bootstrap. And what this is going to do is it's going to install all the dependencies that we need for our project. In our case, because we are just using TypeScript, it's just going to do an npm install. If we were also using Python, it would do both npm and Python. So AlgoKit Bootstrap is a command to kind of wrap all of the dependency installation steps into one. And it also does some other things like preparing env files from templates and just setting up your development environment for you. So always make sure you bootstrap a project when you're getting started. And then finally, we can go ahead and hit yes, create a Git repository, and it's going to open up our new project. And so by default, it'll open up our README, but I'm going to close out of that. We're going to be going over everything in the README in the video anyways. So let's just get right into the contracts and how TypeScript works. So because we named our project digital_marketplace, that's going to be the name of our contract file. Let me expand this out a bit. You can see it's digitalmarketplace.algo.ts. This .algo is entirely optional, but we highly recommend whenever you're writing a contract in TypeScript that you use the .algo.ts extension, because that will help other tools know that this is an Algorand contract. So for example, because it's TypeScript, we can use tools like ESLint and Prettier, but we might have different rules for our contract code and our test code. So using the .algo just helps us separate our two code bases within this project. So I'm going to open up Digital Marketplace Algo. I'll close my File Explorer here. And right away, every template with TypeScript comes up with a calculator contract, except as you can see here, it uses the name of our project as the name of the contract. But what the contract is actually doing is we just have a public method for doing math, and that will be it. So this code kind of gives you an idea of what TypeScript code looks like. And I think that's the first time I've used the word TypeScript. If I use that, just know that TypeScript is the underlying compiler that enables TypeScript to be compiled into our native AVM language. It's what allows people to write TypeScript and ultimately execute it on the AVM on chain. So the language is TypeScript, but the compiler is actually called TypeScript. So that aside, I'm going to go ahead and just delete all this code, because we're going to be going line by line how we can write our contract for our digital marketplace. So we don't need that code. Now, the other thing you'll notice is by default, we have this ESLint disable line. If you prefer not having that comment, you can just simply, you can just simply export your class here, and that'll get rid of that warning. So what we want to do is we want to think a little bit about what we want our contract to include. Now, there are a couple different ways we can implement a digital marketplace. Because this is a beginner series, we're going to kind of go with the easiest way first, and then in intermediate and advanced courses, we'll talk about how we can expand it and make it more feature-packed. But in our very basic contract here for beginner, what we're basically going to do is we're going to have, whenever I have a token that I want to sell, I'm going to create this digital marketplace contract, and that will be what users interact with to actually buy the tokens. So in this digital marketplace contract, I need to have the logic for listing a token and selling the token. Now, even within that, there are multiple different ways we can implement it, but what we're going to do here is going to be fairly straightforward. Now, before actually writing our logic, so writing our methods, one thing I'd like to do is think about the state that we're going to be using in our contract. So for our contract, we know we're going to be listing a token, and we know we're going to be selling that token. So I like to think of the state that is going to be persistent throughout the life of our contract. On Algorand, there are multiple different ways to persist state in a contract. So when one person calls it, the state can update, and then when the next person calls it, they see that updated state. We're going to be going through the different methods of how we save things throughout these various bootcamp courses, the beginner, intermediate, and advanced. But for beginner, we're just going to be using one simple kind of state called global state. And what this basically means is that we can save values directly in our contract, and then we can get them later. So before we actually start writing the code to enable global state, let's talk a little bit about what we want to save. So the first thing I want to save is I want to save the ID of the asset that we are selling. Okay, so when I want to sell something, I create this contract, but that contract should know the ID of the asset that I'm selling. Otherwise, that contract could be used, for selling multiple different assets, which might have different prices, and adds to the complexity. Here, we're just going to have one asset that the contract knows how to handle. On Algorand, assets are not smart contracts. They are just called ASAs, Algorand Standard Assets, and they are primitive features of the blockchain. So instead of referring to a contract address for a token like you would on Ethereum, on Algorand, every asset has a unique ID. So whether it's a one-of-one NFT that has a unique ID or a fungible token, it also has a unique ID. So what we want to do is we want to save that in our state. Now, before writing the code, let's talk about the other thing we're going to be saving, and that is the price. Of course, when people want to buy our token, they should know how much they should pay, and our contract should be able to enforce that they are indeed paying that much. So what I'm going to say, the price of, actually, let me say the cost of buying 1 unit of the asset. Okay, so these are going to be the two things we're saving in our state. Now let's talk about how we actually do it. So for our asset, what I'm going to do is I'm going to create a new property called asset ID. And I'm going to set that equal to global state key. So what this is saying is that asset ID is going to be a key in our global state. So our global state is a bunch of key value pairs in our contract that is persisted throughout the blockchain. And so I'm saying asset ID is going to be the name of a key in our global state key value pairs. And one thing I need to do is I need to define the type that is going to be saved in this key. So the name of the key is going to be asset ID. It's just a string. But the value that we are saving in the key is going to be of the type asset ID. And what this is basically telling TypeScript is that this value that we are saving, it's going to be a number, but it's a special number that corresponds to an Algorand standard asset identifier. So that's how we're going to save our asset ID. And then to save our price, I'm going to say unitary price. And we're going to do the same exact thing here. Now you can see that my Copilot suggested number, but it's important to know that this actually won't work. In TypeScript for Algorand, when we're using the TypeScript compiler, we can't use the number because the AVM doesn't support signed integers and it doesn't support decimals, at least not natively. So in order to use numbers, what we're going to do is we're going to specify uint64. Now the AVM is capable of handling many different types of numbers. In fact, there are even abstracted ways to handle decimals. But the most efficient number that we can work with is the unsigned 64-bit integer. And this is important to note because, like I said, there are many other types of numbers that we can support. You can have a small integer like an unsigned 8-bit integer, or something really big like an unsigned 512-bit integer. But the important thing is that the AVM is most efficient when working with uint64. And importantly, uint64 is the default number type used by all the other native fields in the AVM. So for example, if I'm sending someone a payment and I specify the amount, that amount is going to be uint64. I specify my fee as a uint64. If I'm transferring the asset, the amount I'm transferring is a uint64. The total supply of my asset is uint64. Everything is a uint64, and that's what the AVM knows how to work with best. So that is what we're going to be using instead of our number type. So at this point, what we've done is we've defined a contract. We don't have any logic yet, but we've defined what the state of the contract is going to be. We're going to save our asset ID, and we're going to save our unitary price. So before we go into actually writing our logic, what I'm going to do is I'm going to go ahead and compile this and show you how compilation works. So I'm going to go ahead and just do npm run, npm run build. And we can see here it ran a couple of commands. What we're going to be focusing on, though, is the fact that we have now generated these files under contracts artifacts. you can see we have all these digital marketplace artifacts. So the two artifacts that define the actual logic in our program or in our contract is going to be this approval teal and the clear teal. For most applications, and specifically for this digital marketplace, you can kind of ignore the clear teal. We're not going to be using that. All of our logic is going to be in the approval teal. In later courses, we'll be discussing how the clear program works and more details about that. But for now, we can just focus on the approval teal. This is what the native AVM language looks like. Now, right now, it doesn't look too complicated because there's not a lot of lines of code because we don't have any logic in our contract yet. But you can imagine as we get more logic, this is going to look more and more complex. So the good news is you don't have to worry about this. You just have to focus on the TypeScript. Now, the other artifacts here generated, we have these two files, arc4 and arc32 JSON. These are JSON files that basically describe our application so that front ends and our test suites know how to interact with it. So we're giving our client-side code more information about our contract through these JSON files. And we'll be talking about how we actually use them once we get to our testing. And then finally, we have our source map file. This is just useful for when you run into a bug and you want to debug and figure out what exactly is causing your error. So that's a little bit about the compilation process. And generally, it's good practice that when we are writing our contract, after kind of every function we write, we just make sure it compiles. We're going to be doing proper testing in the next section of the video, but running compilation as a smoke test to make sure everything is working good is a good step in writing our contracts. So we've compiled, we know what we have so far works, but it doesn't actually do anything. We don't have any logic yet. So let's talk about our logic. So the first thing we need to do is define what happens when we create our application. And to do that in TypeScript, we create this create application method. All right, so I want to have a method that I call when I first deploy the contract. This is basically going to be the constructor of the application. And so what we're doing here is we are creating a method called create application. And if we take a look, this comment, this is a special method. This will be the method called when creating the application. And so now in here, this is where we define the logic that is executed when we create it. So what I actually want to do is when I create this, I want to define what our initial state should be. So I'm going to pass in two arguments, right? I'm going to do asset ID, and this is going to be an asset ID type. And I'm going to pass in unitary price, and this is going to be a UN64, right? So let me get rid of this. And so we can see that we define the signature just like any other TypeScript method. We have our method name, arguments with our argument types, and our return type. In this case, we're not going to be returning anything, so it's just going to be a void return. And now to actually set our state values, we're going to do this dot asset ID dot value. That's going to equal asset ID. And then we're going to say this unitary price dot value as unitary price. So now this is a very simple method that when I call create application, we are simply going to allow the user to define their asset ID and the unitary price. Okay, so we have that out of the way. Let me go ahead and do another run build to make sure that everything compiles as we expect it to. And we're good. And now we can go on and talk about the next thing we want to do. Now, there's a couple of different methods that we can implement here. And I'm not implementing them in any particular order, but this first method I'm going to implement is going to be extremely basic and go over a key pattern that you'll see when writing contracts for Algorand. So the method I'm going to write, it's going to be a method for setting the new unitary price of the asset, right? So when I create my contract, I'm going to set the price. In this case, this is just going to be the amount of micro algo that someone needs to pay for 1 unit of my contract. And what this is going to basically do is we want a method to change that, right? So maybe I have some asset that I'm selling and people end up buying it really quick, right? There's a really high demand. And I feel like as the seller that I should increase the price. I should have a function to do that, right? So I'm going to create a parameter called unitary price. And this is going to be the new unitary price. So how do we actually implement that? We're going to say set price, and we're going to pass in our unitary price as UN64. And then we're going to go this unitary price dot value is equal to unitary price, right? So we can see here that this is very basic logic, right? We are taking the same principles of how we set our state in our create application and just apply it to another public method. Now, the important thing here, and this is where we get into a common pattern in Algorand contracts, is we don't want anyone to set the price, right? This logic right now, I could deploy the app and then anyone else on the network could call this set price action or set price method. So now the question is, how do we make it so that only the seller has the ability to set the price? Now, again, there are many different ways we could do this. You could do role-based access control. You could have a whitelist of people, multiple people that could set the price. There's a lot of different complex ways we can do this. But the simplest way is I'm going to say the only person that can change the price is the person that initially created the contract, or the person that initially created the sale. So I'm going to go over here and set price, and I'm going to do an assert. And our assert method is a method that takes a condition, and if that condition is false, our contract will fail. So it won't allow this method to be called if this condition is true. And what I'm going to do, I'm going to make sure the person calling this contract is indeed the person that created it. So to get the person calling the contract, we're going to use this .transaction.sender. And what this is doing is we are getting the current transaction that this method call was invoked by, right? So this transaction is going to be the call to set price. And then we're just getting the sender to see who is actually sending the transaction to call send price. Now what we want to do is we want to get this application and check the creator, right? So we are asserting the person calling set price. So this transaction is the call to set price. The sender is the person calling it, is the same person that created this app. So this app is the app being called, and the creator is the person that created it. Okay, so now we have a function that can update our price, but we've gated it so that only the creator can call it. And this is a very common pattern that we have in contracts where you only want the creator, or if you wanted to get more complex, a specific role to be able to call the contract. And you do that by asserting this transaction sender is equal to some value. Okay, so let me go ahead and let's do another npm run build to make sure that our contract is compiling. And we can go on to our next method here. Okay, so we now have our kind of admin logic set up, right? We have the way for someone to deploy a contract, set the initial state, and then update the state at a later date if they want to. So now, how do we actually begin the sale? So obviously, the first thing we need to do before the contract can sell our asset is the contract needs to hold the asset. We need to send the contract the asset that we want to sell. And to do this, we need to perform what is called an opt-in. On Algorand, because assets are a primitive feature of the blockchain, we have some unique features that aren't in smart contract-based tokens. One of them is called this opt-in feature. And this basically means an address cannot receive an asset if it doesn't tell the network that it wants to receive it. This is kind of like a spam prevention mechanism, but at a lower level, what this allows to happen is that the space that that asset takes up in the ledger can't be used unless the person receiving the asset actually pays for it. So we'll be talking a little bit more about the details of that. The core idea here is that before my contract can receive the asset, I need to tell the network that this contract should enable that asset. And I do that by opting in, right? So I'm going to create a function called opt the contract address into the asset. Okay. And we are going to have a parameter, but we're going to ignore that for now. And I'm going to create a new opt into asset function, and we're going to return void. Okay. So let's first start off about how we actually trigger an opt-in. So on Algorand, an opt-in is a method, is an asset transfer from one person to themselves of the amount 0, right? So if I want to opt in to USDC, I just have to send 0 USDC to myself, and now anyone else can send USDC. If someone tried to send USDC to me before I did that 0 amount transaction, then I would not be able to receive that asset. So what I'm going to do is I'm going to... All right, just wanted to pause real quick because I've seen a couple of people ask this question, and I should have mentioned this at the beginning, so sorry that I didn't. But if you are seeing this error, a fetch error, and it's saying it failed to talk to localhost 4001, what you need to do is make sure you have your AlgoKit localnet running. And so in order to do that, you can run AlgoKit localnet start, and that should start the local network that TypeScript will need to talk to in order to compile your contract. There are ways to get TypeScript to compile without localnet running. However, it's beneficial to have localnet running because that gives you the most features and error checking as part of the compilation stage. So make sure you have your localnet running through AlgoKit localnet start. And then once you have that up and running, you should be able to compile on TypeScript without any problems. So just wanted to mention that, and sorry for not mentioning it earlier. So what I'm going to do is I'm going to send a transaction from my contract. Now to do that, if we type send here, we can see there are a couple different types of transactions that we can do on Algorand. What I'm going to do is I'm going to do a send asset transfer. And I'm going to say the X for asset. So this is going to be the asset that we're actually transferring. It's going to be the asset ID value. The asset amount is going to be 0. And then finally, the receiver is going to be this app address. Okay, so let's talk a little bit about what this code is doing. When someone calls the opt-in to asset method, so let's say Alice calls opt-in to asset, that's going to trigger this, what we call inner transaction. So Alice is the one that calls opt-in to asset, but then the contract itself is going to send an asset transfer to initiate the opt-in. So on Algorand, much like assets, every app has a unique ID. So if we take a look, this .app is just an app ID. So on Algorand, there is a separation between app ID and app address, but that doesn't mean that apps don't have their own unique address. So when we're calling a contract, we need to refer to the app ID, that UN64. But when we're sending transactions to and from the contract, we need to specify its address. And we can get that by doing this app address. Now, you'll notice that I didn't explicitly specify the sender. Oops. This and omitting the sender are the same exact thing. If we don't specify a sender in our inner transaction, it's just going to implicitly be the app address. But the point is that Alice calls opt into asset, and then the unique address that this contract can control is going to send an asset transfer that transfers our asset ID that we have saved in global state to itself, to this app address, and the amount we're transferring is going to be 0. Okay, so at this point, we have seen that when we call opt into asset, we have now opted our contract into the asset. Now, one thing we want to do is we want to make sure that the contract is actually able to opt in. We can't yet opt into the asset because the contract address doesn't have any algo. And in order to opt in, we need to pay for the space that that asset takes on the ledger. So remember, I said that opting in is a way to basically rent that space on the ledger that assets take up. And of course, if I'm an account opting into an asset, I need a way to pay for that space. So as part of our call to opt into asset, what we're also going to require is a payment to the contract. So when Alice calls opt into asset, not only is she doing a method call to this contract, she's also going to be doing a payment to the contract address. And the way we guarantee that is we have an argument. I'm going to call it MBR transaction, and I'll explain what MBR is in just a second. And we're going to say the argument type is a pay transaction. Now, what this is doing, and this is saying, every time I call opt into asset, I must have an atomic pay transaction in the same group. So in Algorand, we can group transactions together and they are forced to be atomic. So this is saying opt into asset cannot be called unless we also do it with a pay transaction atomically. So we've defined that we're going to do a pay transaction, but that pay transaction doesn't guarantee anything about the transaction itself. So what I mean by this is I know every time I call opt into asset, I need a pay transaction, but it's entirely possible and completely valid, given the code I have right here, that this pay transaction is a payment from Alice to Bob, who has no relation to this contract at all. So what we need to do is we need to write logic that makes sure this pay transaction is indeed going to our contract address. So what I'm going to say here is I'm going to call this method verify pay transaction. And I'm going to pass in my MBR transaction. And again, I'll get to what MBR means in just a second. And I'm going to say receiver must be this app address. And I'm going to say the amount is going to be the amount that is required for a new account to opt into an asset. So this amount, we're going to be using our globals. So these are global variables that every contract on Algorand can access. We're going to be saying globals dot min balance. So this is the minimum balance that an account has to hold in order to be valid on the ledger. Any account that tries to go below this min balance will be deleted from the ledger. So we need this account in the ledger. And then we also need our globals for our asset opt-in min balance. Oops. Okay, so let's talk a little bit about this. So in this opt into asset function, we are going to be doing two things. We're going to be verifying the user transaction, and then we're going to be sending our own transaction. And this is a very common pattern. All right, so it's important to remember that when we have a send method, this is sending an inner transaction from the contract address. In this case, we are opting the contract into our asset. When we have a verify method, this is verifying the transaction fields of an external transaction that in this case was sent by our user. So we first do input validation. We verify that our transaction is indeed paying our app the amount it needs. and then we do an asset transfer to actually opt into the asset. Now, you're probably wondering what this MBR transaction is. So the MBR stands for let me just take this out, the transaction that pays for the MBR stands for minimum balance requirement. And what this basically means is every account on Algorand has a minimum balance requirement, or MBR. And this is the amount of algo that that asset needs to, or excuse me, that that account needs to hold in order to remain valid in the ledger. If I try to do something that puts me below the minimum balance requirement, the AVM is not going to let that happen. And the minimum balance requirement, again, is a way that accounts can pay for the storage that their account takes up on the ledger. So if I have an account with just one asset, that is a relatively low minimum balance requirement. If I have an account that holds millions of assets, that's going to be a relatively high minimum balance requirement. And before I can add a new asset by opting in, I have to make sure I have the opt-in min balance. Right now, this is 0.1 algo, but this is subject to change, which is why it's important to use this globals value rather than hard coding the value here. Okay, so here we have our function opt into asset that now enables our contract to opt into the asset so we can then send it. And what we're going to do is just add another cert here, and we're going to do the same transaction sender check as before, right? So the only person that can opt in is going to be the creator. Okay, and let me go ahead and do a compile, npm run build. Make sure that works. I'll take a sip of water. Okay, everything's compiling without an error, and we can go on here. So we've done opt into asset. So at this point, we've done most of the operations that the seller is going to need. But of course, we're going to need a method to buy the asset, right? So method to buy the asset. And in this method, we're going to take two parameters. First is our buy transaction. This is going to be the payment that pays for the asset. Or actually, let me change this. Buyer transaction. And then we are going to also specify the quantity of the asset to buy, right? So anytime I want to buy the asset, I need to include an atomic payment. So I need to pay for that asset, of course. And then I need to specify how much I want to pay for. Now, what I'm going to do is I'm going to first verify our, oops, I forgot to write our method. So we're going to write buy. We're going to have buyer transaction. This is going to be a pay transaction. Quantity, this is going to be unit 64. And this is going to be a void method that is going to return nothing. Okay. And now the first thing, we're going to do some input validation. So I'm going to verify pay transaction. And we're going to verify that the receiver is this app address. And we're going to verify the amount is this unitary price times the value. Now, the other thing we also need to do is we need to verify that the sender of the payment is the same person buying the transaction. Or, excuse me, the same person calling the buy method. Right? So if Bob wants to buy one asset, he needs to make a pay transaction to this app address of the amount that that asset costs. So it would be unitary price times the quantity. And what this does is it makes sure that before we give the asset to the person buying it, that they've paid enough to actually buy it. Right? So we've done our input validation, and now we're going to do our next step, and we're going to send our asset transfer. And as Copilot suggested here, our expert asset is going to be this asset ID. Our asset amount is going to be the quantity that we specified. And the receiver is going to be this transaction sender. All right, so we first verified that our payment covers the cost of the asset that we want to buy. And then we verified that, and then we've triggered the transfer of the asset from this contract to, from this contract to the buyer. Now, another common thing that we want to do, another common input validation, is not only validating our transactions, but also validating our state. One thing I want to do is I want to validate that our price isn't 0. Okay, so I'm going to say this asset ID dot value is not equal to 0. Oh, this asset dot ID, right? Again, asset ID is a separate type from our UN64, so we're going to call ID to convert that to UN64. And so what we're basically going to do is we're going to say that the asset ID must be set. And then we're also going to check that our unitary price must also be set. And so starting the asset ID or checking the asset ID isn't 0 is quite obvious. We're not going to let someone call the buy function if the asset ID hasn't been set yet. And then checking our unitary price is not 0. This is going to allow the seller to temporarily stop the sale of their asset. So if the seller, they're selling really fast and they want to put a hold on the current sales, they can set the price to 0, now prevent anyone from buying it. Otherwise, if they set the price to 0, then people could just drain the account, right? So we're going to have a special condition. When the price is 0, no one can buy it. Okay, so again, kind of high-level architecture of our methods. We're going to do some input validation. First, our state validation. Then our argument validation, in this case, verifying our pay transaction. And then we're going to actually execute the logic once we verify that everything is as we expect it to be. So that concludes our buy function. Let's go ahead and do an npm run build. And we can see here that we run that successfully. And now we can move on to our final method in our contract. So we have our state defined. We have our function for creating our application. Let me actually just add a comment here. Create the application. It's going to be the asset we are selling, the price, 1 unit of the asset. Okay. So we have our method for deploying the asset. We have our method for allowing the seller to set the price. We have our method for allowing the seller to opt the contract into the asset. And then we have our method to allow buyers to actually acquire the asset by sending a payment. Now, the last thing we want to do is how do we close up shop, right? So let's say I list an asset and it's not really selling and I want to get those assets back. And importantly, I want to get all the algo that this contract holds. So what I'm going to do is I'm going to create a new method called delete application. And what this will do is this is another special method, right? The method called when attempting to delete the application, right? So above we have our create application method, and this is a special method that creates our application. And then we have our delete application, and this is a special method that will delete the application. And when we delete the application, we're going to say assert this transaction sender is this app creator. So we only want the creator to be able to delete it. And then we're going to do a send asset transfer. The transfer asset is going to be this asset ID value. The asset receiver is going to be the creator. And now, actually, let's set asset amount. This is going to be this app address dot asset balance of this asset ID value. So our asset amount is going to be however much asset this address holds. Now, if we tried to send this transaction, this would work. But what would happen is, so if we remember, when we first opted into the application, we are increasing the minimum balance requirement of this contract. What we want to happen is we want to be able to get that algo back. So I'm going to add this additional field called asset close to, and we're going to close to the app creator. And what this is basically doing is it's telling the creator, or excuse me, it's telling the ledger that this account, so the account sending our asset transfer, in this case, this application, no longer wants to hold this asset. So when I opt in to the asset, I tell the ledger, hey, I want to pay for the space that this asset is going to take up in my account. However, when I close, I'm basically doing the inverse. I'm saying, I no longer need this space, give me back my money. And so the asset close to is basically going to allow us to reclaim that minimum balance. And this asset close to, if we didn't specify, so if we had an amount of 0, asset close to would automatically check the balance and close, or in other words, and send all of the remaining balance to whatever address we specified. But in our case, we can just specify the asset amount to be the asset balance. So I'll make it a little bit more clear what's happening in Explorers. Now, what we're also going to do is we're going to send a payment. So we now have a way for the buyer to claim back all of the assets. But we also want a way to get back all of the algo in the contract, right? So every time someone buys the asset, we're sending algo to the contract. And what we need to happen is we need to allow that contract to send the algo that it holds to the original seller. So we're going to say the receiver of our payment is going to be the app creator, which is our seller. The amount is going to be this app dot address dot balance. So the amount of algo that this app holds. And then similar to asset, we're going to have a close field. And what this is saying, so when it comes to minimum balance requirement, we haven't increased the minimum balance requirement each time we opt in, but there's also just a global minimum balance that is required by every account on the chain, which right now is just 0.1 algo. So in order for my account to be on the ledger, I need to have 0.1 algo in that account. When I want to delete that account from the ledger, I need to send that 0.1 algo to someone else so my balance can go to 0 and my account can be deleted from the ledger. So what this close remainder field 2 is doing is saying we're going to send all of the remaining algo in this contract to, in this case, the app creator until the amount left is 0. So we're going to empty this account so that our remaining balance of our app address is 0, and therefore it can be deleted from the ledger. Okay, so at this point, we have our delete method. Let me add a comment here. Method to delete the application. It sends the remaining balance and the remaining asset to the creator. Okay. Okay. So at this point, actually, let me go ahead and do our last npm run build. And we can now see our contract has compiled successfully. And so now we're going to be ready to test it. Before we get over to that, let me just show you real quick. If we come back to our approval program, you can see now that all of that TypeScript code that we've written has now been compiled into this low-level tail language. And as you scroll through it, you can see it's a ton of lines of code. It's not super easy to read, and it's exactly why we have this high-level language called, or this high-level language compiler for TypeScript called TailScript. And we can go from this very easy to read, method that it's, or very easy to read class that's just like a regular TypeScript class that has ts.doc comments, has regular method calls, has regular signatures, and convert it into this native AVM language. Now, once we have that, we can start to begin our testing. So I'm going to take a quick break, so there will be a pause in the video. And then when we come back, we'll begin actually testing our contract. So once we have our contract logic and we've compiled it down into that AVM code, how do we actually deploy it to a network and begin calling the methods and testing it? Hope to see you then. All right, so that concludes today's session. Hopefully you found it easy to follow. And as you could tell, being able to write contracts in TypeScript make things a whole lot easier for developers building on it. So that concludes today's session. We'll stick around for a bit in case there are any additional questions coming in. But tomorrow is when we'll get into testing and learn how to use Jest in order to test our contract. So if after this session ends, you'll get a link to the recording. So if you want to catch up on the recording before tomorrow's session, you can go ahead and do that. It should automatically be sent to your email that you registered with Livestorm.
Joe, thanks for this incredible session 1. And maybe the first time that we try to build a smart contract in Algorand, we feel like we don't understand everything, but that is the good part of this bootcamp, that you will have a working example that we can use to build our own solution. And we can take a look of the video and realize the things that you have been doing. As you mentioned at the end, using Python and TypeScript is super easy to start building things on Algorand. We already understand the syntaxes of the language, so we just need to use the implicit function of the language. And today we learn how we can start a project using AlgoKit. We code some functions. We say information in the global state, as you mentioned. We can store information in the local state or in boxes, but we're going to learn about that in the intermediate bootcamp. And we add some security measure in some way to ensure that just the creator of the contract is calling certain functions. And those are important things that we need in production. So our challenge is to review the recordings, replicate the example, and as I always mention, try to create our own functions. And in that way, we realize if we are understanding everything. We have one question that this is super usual regarding that about the set price. Is this method setting the price in algos?
Yes. So in this specific contract, what we're doing is we are setting the price in algos. So if someone wants to buy my token, they have to send the contract algo. We could also change it to accept other assets as well. But for this implementation, we're just going to be accepting algo. At the end of the Python session, what we ended up doing is showing what it would look like to accept other assets as well. So maybe we can do that at the end of our sessions, much like we did Python. But for right now, yes, everything is being paid in algo.
As we mentioned before, for that reason, it's important to participate during these online sessions because you will learn things and you can ask these specific question that can be useful for your own project. Eren asks why we had to use global state for variables.
Yeah, so I mean, Camilo, you mentioned this as well, but developers new to Algorand might not know this, is that there are multiple different ways that we can store state in a contract. So kind of the most standard way that you store state is using what's called global state. And this is kind of the most basic. I have a contract. I want to save some information to that contract. And that's what we're doing with our global state key here. But there are other types of state that we can use. For example, there's local state, which allows you to save information in an account. And then there's also what we call box storage. And this is a less restrictive kind of global state that gives you more data storage. So right now for beginner, we're just going to focus on global state because that's kind of the most basic and where you as a developer should start because it's the cheapest and easiest to work with. But when we get to the intermediate, we'll start talking a little bit more about local state and boxes and when you should consider using those as well.
Because, for example, boxes, all the things that you can do using boxes is unbelievable. And the important thing is how you can create it to ensure the information that you want to store over there. We have over here this one, Python or TypeScript.
Yeah, see, I disagree with this. I love TypeScript, but that's the beauty of building on Algorand is that you can choose either one. And for those of you that have attended both, you'll see that it's incredibly easy to build in both. So, and the nice thing too is that it's not like TypeScript has features that Python does or the other way around. You can build the same exact thing in both of them. So I disagree with this, but that's the beauty of building on Algorand is you can choose which one you want to build in.
And for that reason, we're creating content for the Python developers and TypeScript developers. So you can select, and I already mentioned this. I love Python, but I start using TypeScript and I say, oh my goodness, there are too many things that I can build with this. So I need to learn both of them. Okay. This question, Joe, is wonderful regarding boxes. Are like having a NoSQL DB by your side, I think.
Yeah, exactly. It's kind of like boxes are a good alternative to a database. You can think of it like a key store, basically. So, obviously, you don't have all the features as an SQL database or even some of the more advanced NoSQL databases, but it is, if you think about traditional Web 2 design and you have something that you would use a database for, maybe the Web 3 approach to that solution is going to be using box storage instead of a NoSQL database. The exact pros and cons of it versus other technology we'll get more into in the intermediate, but that's definitely a good way to think about it is when I have something I would store in a database, how can I store that on chain? And box storage is often the solution to do that.
Yeah, that is the most important thing, that this is going to be information that will remain on chain. So what is the kind of information that you want to put over there is up to you, but all the things that you can do using boxes is pretty great.
Yeah,
Okay.
exactly. And even sometimes it makes more sense to put stuff off chain. So it's not always the case that we have to do everything decentralized and on chain. Sometimes as a developer and as a user, it makes sense to use other technologies alongside Algorand.
And a lot of solutions that we are seeing with traction, they are with 2.5 solution that you mix both worlds. So you can use the traditional database and also a part of using boxes. So up to you. What are you building? What are your end user? And what is the product at the end? That is the important thing.
Exactly. And there are even other like Web3 kind of technologies that aren't necessarily Algorand, like IPFS, for example, and using Crust that are useful for hosting things like large files that don't make sense to put on chain. And again, we'll be covering that sort of stuff in the intermediate as well. So we'll be talking a little bit more about kind of our app design and architecture decisions in the intermediate bootcamp.
We forgot to mention this, but yeah, we will have an open repository. I don't know, Joe, if you have the link over there, so you can share with us.
Actually, let me get that.
So you can use the same code that Joe has created for us and add more functionalities. We are expecting that you can help us to create more content for all the algo devs, because maybe you add a specific functionality and I can use the code that Pascal create and I can replicate for my own project. That is what we want after this bootcamp.
Okay, just how to make the repository public, and then we merge this PR, and then I'll share the link in. I think we're good. Okay, so here is the link, and I'll also update the Algorand Bootcamp README, so you can just go there and get the link as well. But for now, you can go directly to this repository. It's Algorand Bootcamp /TSDM beginner EN. And in there, this has the fully completed project. So you can go into the digital marketplace smart contract project, contracts, and then look at digital marketplace.algo.ts to see all the code we covered today. And if you want to take a sneak peek at the test in the front end, you can do that as well, but we'll be covering all of that later in the week.
Awesome. So we learned a lot in today's session and really looking forward for tomorrow's, because we are going to add all the testing that is a recommended practice for all the developers that we start in this world. And I don't know, Joe, if you have another question, something that you want to highlight before we end today's session.
Yeah, I think we're good for today. Again, like Camilo mentioned, testing is a really important part of developing really any solution, but especially on blockchain where things are immutable and you might be working with a lot of money. So definitely tune in to the next session. We'll be covering testing, and I'm looking forward to it.
Okay, we have one last question. Okay, we have two more questions. Maybe we can answer that before ending.
Sure.
Okay, the first one is for some ASA standard like ARC3. I saw that there is recommendation to use IPFS, other storage services to record metadata.
Yeah, so
if it's not in boxes referred to.
Yeah, so this right now we have a couple of different standards for tokens on Algorand. Again, we'll be going more in depth in the intermediate session. And those standards, generally how it works is you have your actual token that you trade on chain, and then metadata or an image that live off chain. And right now, the standards recommend using IPFS. If you wanted to, you could also use like a traditional, like Web 2 server, but of course we like things decentralized, so we recommend IPFS. And right now, there aren't any standards for putting that kind of data on chain in boxes because there isn't a whole lot of use, especially if it's just like an image file. There really is no need to put it on chain. But for stuff like metadata or like token properties, you could see some potential value there. So it is something worth thinking about. But yeah, right now, all of our standards recommend using IPFS or off-chain solutions rather than putting it on-chain in boxes.
Okay, the next question is for me. What we are going to offer for the people that participate during all the bootcamp sessions. So we're working with the DevRel team, and we're going to create a series of challenges. And the people that can solve those challenges are the ones that participate and have claimed all the certificates. And obviously, we can add more surprises, but we are working on that. So please stay tuned, because after the intermediate ones, we are going to announce the surprises. Okay, so thank you so much for joining us, and see you tomorrow. Thank you, Joe, for this amazing first session.
All right, thanks, Camilo, and thanks everyone for watching.
Bye.